All right, we're going to do one little brief kind of derivation for you, and mostly that's because in your section 3.2, when you're doing some of your homework, there's one more rule that I did not put in my actual class notes that I have for you, so we're going to add it right here, and that is the derivative of e to the x with respect to x. I'm going to put a star by this one. This is a really important function in calculus, and you'll see why here in just a second. But we want to try to take the derivative of this. And again, we're going to do the proof. So we're going to show the limit. So we're going to take the limit as h goes to 0 of e to the x plus h minus e to the x all over h. So we apply our limit definition. Now basically I'm going to do a little factoring. Maybe let's kind of remind ourselves little exponent rules. This is the same as e to the x times e to the h, because you add your exponents, minus e to the x over h. I'm going to factor out the e to the x. We have e to the h minus 1 all over h. So we're going to basically remember that we are taking the limit as h goes to 0. So e to the x is a constant, so I'm going to be able to pull that out. Okay, so this would be e to the x times the limit as h goes to 0 of this e to the h minus 1 over h. All right, now I'm just going to recall something. You've probably heard this before, but if you don't remember it, kind of a definition of e. That e can be found by doing the limit. I'm going to use h as h goes to 0 of 1 plus h to the 1 over h. This is and this limit, no matter what values you do, this is going to always end up being equal to e. That's kind of a definition of e. So basically what that tells us is that for small values of h, when h is small, 1 plus h, 1 over h, should be approximately e. Should be kind of close to e. Okay? And what that basically is going to tell us is that e to the h can be approximated. So let's do an approximation. When h is small, we can approximate that as 1 plus h to the 1 over h to the h, because e is what's inside of here. This is e to the h, which is going to give us 1 plus h when h is small. And the idea or the trick to this little kind of proof, and we can verify this with the sandwich theorem and do some other things, but that we can basically take out, because we're letting h go to 0 anyway, that what we can do is do this and do the limit as h goes to 0 of 1 plus h minus 1 over h, and use that as a replacement for e to the h, because when h is small, like it is when it goes to 0, they are essentially the same. And what that gives us in our kind of string of definition here, 1 and 1 will cancel, h over h is 1, the limit of 1 is 1, so we get e to the x. So the derivative rule for e to the x, the derivative of e to the x with respect to x is itself. It is the only function that exists whose instantaneous rate of change is the y value of the coordinate. If I were to look at just a picture of e to the x, and we come across and say there's a point, this point is 1e. And then I say, what is the slope of the tangent line at that point? The slope is e. The y value and the slope are the same, no matter where you are on the curve. If I go to the point over here, 2e squared, then the slope of that tangent line, the instantaneous rate of change, is going to be e squared. It is the only function whose rate of change is itself. And that's an interesting phenomenon. But you will be using your e to the x for your derivatives. So, I mean, it's kind of a straightforward derivative when you see it. Let's just do a couple of examples since I don't have this in that packet of notes for you. But if I wanted to find the derivative of each of the following, find f prime of x. So if f of x equals 3e to the x, f prime of x equals 3e to the x. Hey, we're done. Nice and easy little problems. If you see something like f of x equals x squared plus e to the x, your derivative would be 2x, that's power rule, plus e to the x. What you want to not be tempted to do not use power rule when you are doing the derivative of e to the x. It sort of looks like a power function, but it is not. A power function is x to a real number. This is a number raised to the x, not the same thing. So you can't use the power rule, you have to use the exponential rule, which is its own derivative. So don't tell me xe to the x minus 1. That's the most common mistake I see. So just be very, very careful about that. Let's do one more example. If I said f of x equals sine of x minus e to the x, then its derivative would be the derivative of sine, cosine of x, derivative of e to the x, e to the x. Okay? So that's a pretty straightforward one when we're looking at it. And that kind of should give you kind of the small set of derivative rules that you're going to need to have in your flashcards. So let's just kind of recap where we are. If I want to take the derivative of a constant with respect to x, you get 0. If I want to take the derivative of x to a power with respect to x, I would get multiply the front, x to the n minus 1. Okay? If I wanted to take the derivative of a sum or difference of two functions, then I would simply take the derivative, and I'll go ahead and do the prime notation, take the derivative of f, and then add or subtract it to the derivative of g. The derivative of sum or difference is the sum or difference of the derivatives. The derivative of a constant times f of x, a constant multiplied times a function. You simply pull the constant out and then take the derivative of the function. And that also is why we don't really need a separate little rule for this. That's why the derivative of ax to the n with respect to x is simply a times nx to the n minus 1, because the constant is pulled out front. So that's not really a different rule. It's just kind of using the constant multiplier rule with power rule. And then you have your, kind of do a thorough list of what's in this section. The derivative of sine of x with respect to x is cosine of x. The derivative of cosine of x with respect to x is your negative sine of x. And your last rule that's in this section, and again, make yourself some flashcards because there are more to come. The derivative of e to the x with respect to x is e to the x. Okay? If you have any function that you are trying to take the derivative of, right now it must be the sum or difference of either a constant, a power function, a sine, a cosine, or e to the x. That's what you know how to take the derivative of. If it is not the sum or difference of the sum of these types of functions, then you must rewrite it. If you're in this section, you have to be able to rewrite it as the sum or difference of one of these basic rules that you're going to know.